Welcome to today's lesson about symmetry. Woohoo! I think you'll enjoy this one. This one's not as difficult as some of the other ones that we've had. So, first off, what does it mean if something has even symmetry? Well, the way that we're going to define it in this class is something has even symmetry is if I were to, looking at this graph right here, if I were to rotate it around the y-axis, which is this line right there, then that would be, and if I rotated around that line and I got this graph right here, which is the same thing as the original graph, then we say it has even symmetry. So if you can kind of imagine, I can't do this on the iPad, but me taking this graph number 1, and rotating it around the y-axis, kind of taking the paper and flipping it upside down. And then if I can see through it, and it looks exactly the same as when I flipped it over, as before I flipped it over, then we say that one has even symmetry. Okay? There's another kind of symmetry, and that is called odd symmetry. And this one I can show you a little better visually what that means. So we say something has odd symmetry is if I can take the graph, this one right here, and if I take it and if I flip it upside down like this and rotate it 180 degrees, if I get the same graph that I started out with, if you look at graph number 2 and graph number 1, they are the same. All the points on each of these two graphs would line up exactly. So we say that this one has odd symmetry. One way that teachers have used to help students remember the difference between even symmetry and odd symmetry is the John Travolta. Maybe your parents would get this a little better, but John Travolta often had his arms going like this when he was dancing, and he was a bit odd. So, since Mr. John is odd, and his arms were like this, that is what odd symmetry is. Okay? So let's look at some example problems. Does this one right here have odd or even symmetry? Well, let's do the first test by looking at it. If I were to rotate this around the y-axis, take this graph, and somehow be able to rotate it around like this, flip it upside down, would I get the same graph? Well, no, I wouldn't. If I were to rotate this around the y-axis, I would end up with that's pretty awful. Let's try redrawing it. So let's draw it right on this graph. I would end up with a graph that looks like this. Not quite. Let me try and make that a little better. Yeah, it looks something like that. And so it doesn't line up with the original line after I rotate it around the y-axis. So therefore this one does not have odd symmetry, or does not have even. So no even. Well, then you might be wondering, well, does it have odd symmetry? So if I were to take this graph, if I flip it upside 180 degrees, is it the same? Well, no, it's not the same as when I started out. If I rotate this 180 degrees, it's a different graph. It doesn't line up with its original graph. So therefore, this one doesn't even have odd. So since this one doesn't have even or odd, we say it has no symmetry. No symmetry whatsoever. Okay? So let's look at another one. So this one right here, it's the same graph on the left and the right. Let's see which one it has. So let's test even symmetry first. So if I were to rotate this around, flip the paper over, flip it upside down, would I end up getting the same graph? Well, no, I wouldn't. I would end up with a graph that looks like this, where it has this guy, it comes out like that, and then this guy comes out like that. So it does not have even symmetry. Let's check to see if it has odd symmetry. So if I take this graph, and if I were to rotate it 180 degrees, let's take the left one and rotate it. If I were to rotate this 180 degrees upside down, the graph now fits right on top of the other one. Fits right on top of the other one. So therefore, it does have even symmetry, or odd symmetry, sorry. Because if I rotate it around 180 degrees, it does line up directly on the other one. Okay, let's look at one more example. Alright, so did this graph have even, oh, I didn't answer the last one. I want you to always write the answer, not just think about it. So this one has odd symmetry. Symmetry. Okay. Let's move on to the next one. So, does this one have even or odd symmetry or no symmetry? Well, let's check. So if I were to take this graph, if I rotate it around, checking for even symmetry, rotate it around the y-axis or flipping the paper over, would I get the same graph? Well, yeah, I would. This line right here, didn't trace it very well, would end up being on this side right here. And then this line, the line on the left, would end up being the same line on the right. So it does have even symmetry. If you have a paper that you can see through, it's pretty easy to do this test. Does this graph, so let's label it, so it has even symmetry. So let's check to see if it has odd symmetry. You can probably already see now that if I flip this 180 degrees upside down, I have a different graph. So therefore this one does not have odd symmetry. Okay? Let's look at another example. This is going to be, or actually, now that we've done these, we're actually just going to talk about some tricks of the trade. Some tricks of the trade. Okay. First trick of the trade. If it doesn't go through the origin, then it doesn't have symmetry. It is not symmetric. So what I mean by this is if the graph somehow, if it doesn't go through this middle part, this is called the origin. The origin's at 0, 0, where the x and y axis meet, then it's not going to have any symmetry. Let's see if this is true with the ones that we did. So this one went through the origin, and it did have even symmetry. This one went through the origin, and this one was odd symmetry. This one did not go through the origin. There's no crossing of the line, and there was no symmetry. And this one, it did go through the origin, and it did have, had odd symmetry. And this one went through the origin and had even symmetry. So it holds for these examples, and it will hold in every case, meaning it will work every time. So it makes your life a little easier. If it doesn't go through this point, it's not symmetric. Case in point, that's simple. Another trick of the trade. It can't be odd and even. It's going to be either or. So once you find out if it's odd or even, then you don't have to test the other test. So, and that's proved with all of our examples. This one was only even, it wasn't odd. This one was only odd, it wasn't even. And this one was neither. This one was only odd, it wasn't even. And this one was only even, it wasn't odd. So there are a couple tricks of the trade to help you work through a little quicker. If you're stuck on the other columns on this assignment, look at the video before this one on how to do those. Thanks for watching.